Alright, in this video we are going to continue our discussion on electron configurations. If you have not watched the previous video, you probably want to stop this one and go back and do that, as it conceptually should make a little bit more sense. We've already talked about how to distinguish or how to draw an orbital diagram, an orbital configuration with respect to electrons. An electron configuration is a bit shorter. It doesn't show the actual electron placement within each orbital, it just tells you how many electrons are within each sublevel. So, same example problem, we're going to draw the electron configuration for nitrogen. Your slides actually have a typo, I believe. This probably still says noble gas configuration. Just cross that out and put in electron configuration, please. Nitrogen still only has 7 electrons, though. So we're going to show you where those are located. We need to fill the electrons in from the lowest energy level. We always start with the first energy level. Looking at the first energy level, the first sublevel is always S, and 2 electrons can fit in that S sublevel. So we're not going to draw arrows or anything here. We're going to put a superscript 2 to indicate that there's 2 electrons in there. Now that sublevel on the first energy level is full, so we need to move up to the next orbital, lowest energy orbital. We always fill from the lowest energy to the highest. The next one is 2, the second energy level. We're on the second row of the periodic table. It's also an S sublevel. So it 2 can only fit 2 electrons in it. So now we've filled 2 plus 2. We've accounted for 4 of nitrogen's 7 electrons. We need to keep going. Looking at your periodic table, there's a 2p sublevel. The p sublevel is, if you count, it's 6 blocks wide, so it can fit 6 electrons. However, we only have 3 left, so we are only going to put 3 in it. Now we have 2 plus 3 is 7 electrons, and we've drawn the electron configuration for nitrogen. So this notation, just to make that concrete, the 3 tells you the energy level of the electron's location. It also corresponds to the row number on the periodic table. Each row is a higher level of energy. The P we call a sublevel. It indicates the type of shape the electron would make if you plotted its path over time. For example, the P was a dumbbell shape. And the 5 indicates the number of electrons in that sublevel. That's electron configurations. We have one more, which typically after people figure out is their favorite because it's the shortest. The noble gas configuration just shows us where the highest energy level electrons are located. Those highest energy level electrons are called the valence electrons, and they are important because they're the only ones that ever get involved in bonding, regardless whether it's ionic or covalent. The lower energy level electrons don't typically become involved. So for our example problem, once again, I think I had a typo. Your notes say orbital configuration. If they do, please change that to noble gas configuration. And we're still going to keep nitrogen, which thankfully still has 7 electrons. Alright, so our first step, identify the highest energy level for that atom. We do that by looking up the row placement on the periodic table and finding the row number. So nitrogen has an atomic number of 7, and if you look all over the way over on the left hand side, it is row number 2. So that is going to be its energy level. So we are going to write the electron configuration, which was the previous slide. We're going to write the electron configuration for only the electrons that fall in the second energy level. And specifically the S and the P We skip the d electrons for reasons that we'll talk about in the next slide. But the s and the p electrons are the ones that are in the highest energy level. Thankfully, I have that written twice now in my handwriting as well as print. So our second energy level for nitrogen, the first sublevel we come to as we read our periodic table, we're going to read it like a book, if you will, from left to right. The first sublevel is S. So the 2s sublevel can fit 2 electrons. And then we run into the P sublevel. And there are 1, 2, 3. You kind of count your way over to nitrogen. And yes, B is the element with the atomic number of 5. It's 2p is the first box. So 1, 2, 3 over to nitrogen. So 3 electrons would fit in the 2p. So this tells us where our electrons are. We have 2 in the S and 3 in the P. The one thing I didn't state that I should have started out with, and it's also not in my instructions, I realize, is that in square brackets we need to state what noble gas falls just before nitrogen. And you put those in square brackets. So here we have a set of square brackets. In it we want to put the abbreviation for the noble gas atom that falls just before nitrogen. So look at your periodic tables, and as you look at your periodic table, most people immediately want to say neon. Well, neon has 10 electrons. Nitrogen only has 7. So we don't want to say neon here because that would indicate more electrons than what nitrogen always has. So the noble gas that you put in parentheses is always the one on the row above whatever element you're doing. So we are writing out the configuration for nitrogen. The noble gas that falls right before it is helium. Helium has 2 electrons, nitrogen has 7. So if we put helium here in square brackets, helium had 2 electrons, plus 2 plus 3 gets us to our 7 electrons. So if you're unsure of which atom, which noble gas, specifically anything in column 18, should go in square brackets, you can always do the mental math after you've written it out and make sure you've come up to the total number of electrons. The noble gas configuration gets really convenient really once you start getting down to elements that have, 15, 20, 30, 40, 50 electrons, because the last thing you want to do is start with 1s2, 2s2, 2p6, and write all of that out. It's much more convenient just to be like, hey, it's argon's noble gas configuration, and then 4s1. So it has 1 more electron than argon. If you look at your periodic table, the one that has 1 more electron than argon is going to be the one that's the next block over, which is potassium. So this is K. All right, we have one more thing, and then we will be done for today. Our D level electrons, those are this portion of the periodic table. Let's look at row 4. We have 4s, that's our S sublevel. And then we get over to the D block, and it says 3D. It's not a typo. The 3D sublevel is actually at a higher energy level than the 4s sublevel. So when you're filling electrons for any atom that has more than 21 electrons, you're going to start putting the electrons in the D sublevels. So you need to remember, because you won't have this chart given to you normally with all the orbitals filled in on it, you need to remember that the D block of the periodic table, the energy level is always 1 less than what it states over here. And like I said, that's because they're at a higher energy. So conceptually and theoretically, we fill those later. So for titanium, let's just do the noble gas configuration. We have to find titanium. Titanium's right here. The noble gas configuration, you always find the element in column 18 that falls just before titanium. In this case, that would be argon. So we're going to do argon in square brackets and then write out the rest of the electron configuration for titanium. So it's in row 4, S, there's 1 box, 2 boxes, so 2 electrons go in the 4s2, there's the 4s sublevel, and then we're 1, 2, we would have 2 more electrons left that would end up going in the 3d sublevel, so 3d2. So typically when you are writing out an electron configuration, you would skip, when you're writing out a noble gas configuration, you would skip the D sublevel if you wanted to indicate valence electrons only, because valence electrons only, 4 is a higher energy level than 3. So if you're trying to figure out which electrons are going to be involved in bonding, these two would not. So you'll have to ask or make sure the instructions are clear on whether or not you should include the D sublevels or just put the ones in the noble gas configuration that are at the highest energy level. It can go kind of either way, honestly. And that's it.